So in the last class, I was discussing polar coordinates with you. So what was the position vector in terms of polar coordinate? In polar coordinates, if you are using polar coordinates, then what is the position vector? R will be equal to R and this will be R cap. Okay. So position vector was equal to R into R cap. Yes, beta, please. Now, what will be the velocity? In this case, we have find out in the last class that was R dot R cap plus R theta dot, and this will be theta cap. So in the last class, by using polar coordinate, I find out the position vector R vector equal to R cap, and velocity in terms of polar coordinate will be R dot. This R dot, this is known as radial velocity. In general, it is known as radial velocity, and this R theta, this is called as tangential velocity. Okay, VT. So what is V here? V is here equal to VR R cap plus R, this is VT, and this will be theta cap. It will be like this. Now next is acceleration. So you know position vector, you know velocity in terms of polar coordinate. So next will be the acceleration. So what will be the acceleration? So basically I will use this equation for acceleration. So acceleration is given by, instantaneous acceleration will be given by dv by dt. This will be dv by dt. Now this is v. So start differentiating this with respect to time. So first differentiate this r dot. So this will provide you r double dot. R double dot, this will be r cap. Second, keep r dot as it is. This will be r dot, and this will be dr cap by dt. So first two term will be this. Now differentiate this with respect to time. So first will be plus, it will be r dot, differentiate r with respect to time. So this will become r dot, theta dot, this will be theta dot, theta cap. So first I have differentiated this r. Second, differentiate this theta dot. So this will be plus r. This will be theta double dot, and this will be theta cap. Okay. Next is plus this r theta dot as it is. Now differentiate this theta cap. So this will be d theta cap by dt. d theta cap by dt. Now, if you look at this is r dot r cap here, that is okay. So what is the value of this dr cap by dt? In the last class, I find out dr cap by dt, it is theta dot theta cap. Substitute here, okay? Theta dot theta cap in place of dr cap by dt, and in place of this d theta cap by dt, that will be equal to minus theta dot r cap. So if you combine this term and this term together, so here this is r double dot r cap here.
Theta dot r cap.
Yes, beta.
तो minus theta dot r
Okay.
cap आएगा अपने आप.
Where?
So d theta cap by dt.
हाँ, तो this is minus, this will be r cap. Okay, this will be, you are correct. This will be r cap. So here, this is r cap, r double dot. So I can write acceleration like this. This acceleration will be, this will be r double dot here. So I have used this term. Second, this will be minus here, and this will be r theta dot square r cap. So this will be minus r theta dot square, and this will be r cap. So this is the radial acceleration. Okay. Next, This term I am using, this is theta cap. I am using theta cap. So plus this r theta double dot. And if you look at this term, this is r dot theta dot. This is also r dot theta dot. So this will be 2 times r dot theta dot. And this will be theta cap. So this is the expression of the acceleration in terms of polar coordinate. So this component, this is called as radial component of the acceleration. You call it as AR, r cap, plus this is called as tangential component of the acceleration AT, okay, and this will be theta cap, theta cap. So this is A. So basically expression of the acceleration in terms of polar coordinate is this one. This is. Okay. So basically here, in terms of polar coordinate, if a particle is moving in a plane, then 2 type of acceleration will be possible. One will be the radial, AR, and another will be AT, tangential or transverse. Transverse to the radial position. So this will be AT, theta cap. So 2 type of acceleration will be possible. Now, if you know AR, you know AT, then what will be the Newton's, or you can say equation of motion? So now in polar coordinate, how can you write equation of motion? So if there is a force that is acting in the radial direction Fr, then this Fr will be responsible for the acceleration in the radial direction. So a force in the radial direction, it is a cause, and what will be its effect? Its effect will be the acceleration in the radial direction. So this will be MAR. So this Fr is the cause, force in the radial direction. It will cause an acceleration in the radial direction. So that will be MAR. Similarly, if force is acting in the tangential direction, you can write it as F theta. Then this will be responsible for this acceleration AT in that particular direction. Or you can write this M. What is AR? AR is R double dot minus r theta dot square. Theta dot square, and this will be Fr. This will be Fr. And this one, this will be mass, and this will be r theta double dot plus 2 times r dot theta dot, and this will be F theta. So these are the equation of motion, okay, equation of motion in terms of polar coordinates. So here force is the cause, they are the causes Fr and F theta, and these are the effects, these accelerations, they are the
And
effects.
one is the force of radial force and another is the
tangential force beta. Another is tangential force, Ft or F theta. Okay, Ft or F theta. So these are the equation of motion. So basically now you know position vector, you know velocity here in terms of polar coordinates, you know acceleration as well as equation of motion, So you know everything that is required for the kinematics. Okay, so now you are ready to solve questions of kinematics in terms of polar coordinates. Okay, in terms of polar coordinate. So one of the best example or one of the good example to understand these polar coordinate is uniform circular motion. So first I am going to apply all these concepts, whatever we have learned here, on the uniform circular motion. Is this clear to all?
Sir,
Yes, beta, please.
sir, tangential acceleration, you are denoting AT, but
AT, or you can
force.
write it as A theta. If you want to write, you
Okay,
can
sir.
write it as A theta.
Okay, sir.
ठीक है? AT or A theta. This is your choice.
Sir, can you explain the cause and effect?
Basically, whenever you are applying a force, what this force is going to do, either it is going to give you acceleration to the object on which force is applying, or it will try to do. Okay? If it will try to do. So basically, when you are applying a force, what will be the result of it? An acceleration. Okay? So force is the cause, and due to this applied force, there will be some acceleration. So that acceleration is the effect. Okay? So the equation of motion is actually the cause and effect relation. Cause and effect relation, that is called as equation of motion. Now, come to this uniform circular motion as an example. Uniform circular motion.
So can you show the previous slide?
Yes, beta?
Previous slide, can you?
Okay. Uniform circular motion. Next is uniform circular motion.
Okay, thank you, sir.
So, what is uniform circular motion? If a particle moves, moves on a circle with constant speed. I'm not saying velocity, with constant speed. Constant speed. So what I'm saying, if a particle is moving on a circle with a constant speed, then its motion is called uniform circular motion. Then its motion is called uniform circular motion. Uniform circular motion. Now, look at, so what we are saying that there is a particle, it is undergoing motion on the circumference of a circle. So here there will be center and particle, it can move on the circumference. Suppose mass of this particle is m. So here, if this is the center of the circle, then this particle will always be at a constant distance. Remember this, if r is the radius, of this circle, okay, on the circumference of which this particle is moving, then this particle will always be at a constant distance for the center, and this is a two-dimensional motion. What it will be? This will be a two-dimensional motion, and here this particle will be at a fixed distance from this center. So this type of motion where particle is undergoing two-dimensional motion and its distance from a fixed point is constant, as well as its speed is constant, then that type of motion is called as uniform circular motion. Uniform circular motion. So what is the radius? You are going to call it as origin. We are considering it as origin. So I can say this is suppose x-axis. This is suppose y-axis. So they are x and y axis. Okay, here. And I'm going to use the polar coordinates here. So what will be the radial position of this particle? Throughout its motion, its radial, radial distance from the center, this radial distance will be r. If radial distance is r, then you know that this r dot, it will be 0. R dot is 0. Okay? So r dot is 0 here. Second thing, what they are saying that it is moving with a constant speed. It is moving with a constant speed. So what is the meaning of this? Okay, first we have to understand. So first I'm writing the velocity of the particle that is undergoing this circular motion. So you can write velocity of the particle. You can write velocity of the particle. First is velocity of the particle. Velocity of the particle. So what will be the velocity? Velocity expression is v vector, and this will be r dot. Try to understand, this will be r dot, r cap in polar coordinates, plus this will be r, small r is equal to capital R, and this will be theta dot. Theta dot is the angular speed, and this will be theta cap. Theta cap. Now r dot is 0, so automatically this component will be 0. So you are saying that VR, radial component of the velocity or radial velocity of the particle under uniform circular motion, it will be 0. Even in case of non-uniform circular motion, this will be 0. Now, what will be the velocity now? It means only tangential velocity is there. So this V is equal to, r theta dot. And what will be direction? That is theta cap. So this is only Vt. ठीक है, tangential velocity. Only tangential velocity is there. This particle is going to have only tangential velocity if it is undergoing uniform circular motion. So what this equation is telling me that it is going to have only tangential velocity. And how much it will be? It will be capital R into theta dot. Capital R into theta dot. So you can write here, in case of uniform circular motion, only tangential velocity exists. In case of uniform circular motion, only tangential velocity exists, comma, radial velocity VR will be 0. Radial velocity VR will be 0. So only this will be there. What will be the direction? Direction of this velocity, tangential velocity, is continuously changing. So you cannot say that velocity is constant. Velocity is changing. Speed is constant, but direction is continuously changing. So what I am saying here, velocity is equal to Vt theta cap or r theta dot. This r theta dot theta cap. This is. But remember this. Okay, this is velocity. It is having both magnitude as well as direction. So its magnitude is Vt. This is the magnitude, or you can say this is the speed. What you can say, this is the speed. So speed is constant, or you can also write it as, in place of theta dot, you can also write it as omega. You can also write it as r omega. What is omega? Omega is the angular speed. Theta dot or omega. This is angular speed. Angular speed. So angular speed is constant, magnitude of its velocity is constant, but direction is continuously changing. Here, this is the direction. After some time, when this particle will be here, its direction will be changed, magnitude will be same. So it will be Vt. It will be Vt. So this Vt, this will be constant, but its direction is continuously changing. Okay, so this Vt is there. So you can write here, magnitude, you can write here magnitude of the velocity, that is speed. Magnitude of the velocity, that is speed, will remain constant throughout the motion. Will remain same throughout the motion. However, its direction will continuously change. However, its direction is continuously change. However, its direction will continuously change. So, velocity of the particle is not constant. So, velocity of the particle is not constant. ठीक है? Velocity of the particle is not constant.
Sir, please hold the last.
Just a bit. So, velocity of the particle will not be constant. Is it clear?
Yes, sir.
Now, if velocity is not constant, try to understand, then linear momentum will not be conserved. So here, linear momentum will not be conserved. Will not be conserved. ठीक है, अभी I will again come to this point here. Here. Now you are saying it's speed, Vt. We are saying Vt, that is R theta dot. ठीक है, this is constant. This is constant. Magnitude is constant. Now, remember this, what is this R? This R is capital R. And this is theta dot. And you are saying this is a constant. Constant. So what you are saying, this capital R is a constant. Now, this R is also a constant. So what you get here from here, because R is constant, right hand side is a constant, it means angular speed in this case. Angular speed. Speed theta dot equal to omega. This is also a constant. So what we are saying here, we are saying that radial distance of the particle is constant. We are saying R dot is constant. Okay? So R dot is 0, not constant, and R double dot, if you find out, that is also 0. Okay? Second, we are saying that this Vt, that is Vt equal to R omega, that is a constant. That is a constant. And now we are saying this omega. Omega is also a constant. So omega is constant, tangential velocity is constant, and this radial distance from the center, it is going to be constant in case of uniform circular motion. Next is acceleration, but come back to the acceleration so that I will again focus on it. Okay? I'm going to again focus on it, on this aspect. So next you can write acceleration here. This was the first part where we have investigated. You can write it as a velocity of the particle. Now we are going to look into the acceleration. So now that is acceleration of the particle. Acceleration of the particle. Next is acceleration of the particle. Of the particle. Okay. Now you know what is the expression of acceleration in terms of polar coordinate. What is acceleration? Acceleration, it will be equal to, okay, radial component of the acceleration AR R cap plus AT, you can write, or A theta, whatever you like. This will be theta cap. It will be like this. Okay, this will be. Now, what is AR? AR is R double dot minus R theta dot square. And this will be R cap. Plus, this will be R double dot plus 2 times R dot theta dot, and this will be theta cap. Theta cap. If you look at R dot is 0, if you look at R dot is 0, then this R dot is 0 here. So this will be 0, beta. This will be 0. And this R double dot is 0. This R double dot here, this is not, this is correct. Yes, please. This will be R theta double dot. Okay, this will be R theta double dot. So this R double dot will be 0. So please correct it. This is the first time R double dot is here. This is R theta double dot. Now, what you are saying, theta dot is constant. So from here, you can write theta double dot. That will be 0. Okay. So please correct it. First term, this is R theta double dot. So this will also be 0. So what is left with us? that is only this radial acceleration, acceleration in the radial direction, and that is also with minus sign, negative sign. So what is the acceleration here? Acceleration.
R theta double dot means 0 means R is 0.
No. R theta double dot 0 means, we have find out that this angular speed or angular velocity, okay, this omega, this is constant. This is constant. ये speed क्या velocity होगा, ठीक है? What will the direction of this omega? Can anyone tell me what will the direction? Actually, it is rotating like this, so this will be the direction of the thumb. It will be omega, so omega will also be, direction will also be constant, so you can also write it as angular velocity. Angular speed will be constant, but angular velocity, that will also be constant. So here, what will be the acceleration? Only one part, radially inward. This negative sign is saying that this acceleration is minus r cap direction. This acceleration is in which direction? This will be r theta dot square, and this will be r cap. So what is the direction of this? Only radial acceleration
gives
is
that the omega.
Yes.
Theta dot gives the omega. Then omega is constant. Then theta
Yeah.
double dot is
0. What is theta dot? Theta dot is omega constant, so theta double dot will be 0.
Yes,
So this will be minus r theta dot square r cap. So basically only one type of acceleration is there, that is acting radially inward. So this minus sign is representing that this acceleration is radially inward. So you can write here acceleration is in radially inward direction, is in radially inward direction.
Sorry, inward is because of minus sign.
Because of minus sign. So direction is minus r cap. ठीक है? Direction is minus r cap. So inward direction towards the center. Inward direction. And this acceleration is called as centripetal acceleration. What you call it? You call it as centripetal acceleration. So what this acceleration is, you can write this is A actually. Okay? You can write it as AR r cap, and this is minus r, small r is capital R, and this will be theta dot square r cap. What you call this acceleration? You call this as centripetal acceleration. You call it as centripetal acceleration. That is always acting toward the center. This theta dot, or you can also write it as, I can write this AR as minus r theta dot square, or even you want to write, you can write it as r omega square. Okay? Now, tangential velocity Vt, that is r theta dot, or you can write it as r omega. So theta dot, it can be written as Vt upon r. Substitute here in place of theta dot square. So this AR, that will be minus r theta dot square, or you write it as minus r omega square, or you can write it as minus, from here if you substitute, one r will cancel out and you will have Vt square upon r. And this is the expression of centripetal acceleration. Here throughout this minus sign, it is representing inward direction of the acceleration. So this is the expression of centripetal acceleration towards the center. So what will be the corresponding force? So centripetal force, corresponding force will be centripetal force. Centripetal force. That will, you can write it as a FC. and Fc will be minus V square upon R, and this will be R cap.
V square
So-
upon R square, right?
mv square m से भी multiply करोगे, not R square. F equal to m में, ठीक है, F will be m में, even I can write like this, F equal to m into acceleration like this. So Fc will be equal to minus mv square upon R. 1 R will cancel out. 1 R is here. If you are substituting Vt square upon R square, then 1 R will cancel out. So here in denominator, you will have only 1 R. So this will be R cap. So in general, you are well aware about this form of the centripetal acceleration. Okay? So in case of uniform circular motion, only one type of velocity is there, that is tangential velocity. Okay? Only one type of velocity is there, that is tangential velocity, and only one type of acceleration is there. Okay? That is radially inward acceleration. Tangential acceleration is 0. So what we are having in uniform circular motion,
Can you show previous slide?
yeah, just please.
No, sir, one से इससे भी previous वाली. Thank you, sir.
Welcome to. Now, in case of uniform circular motion, yes, we are having Vt, that is R omega. Okay, and that is constant. Why it is constant? Why it is constant? It is constant because tangential acceleration At is 0, or no force, it means no force is acting in the tangential direction. Acting in the tangential direction. That's why this speed is constant. Okay? Why this speed? Okay? This is a speed of the particle. Why it is constant? Because acceleration, tangential acceleration, or the force in the tangential direction, okay, that is 0. There is no force that is acting in the tangential direction. Okay? Only one acceleration is there, that is radial acceleration, inward acceleration, V square upon R. Okay? Minus V square upon R. Okay? If you write it, okay, you are going to write it. So this will be R cap. This will be R cap here. So basically, only one force is acting on it. So force, that is centripetal force, it is acting toward the center. So now what is the situation you are talking about here? You are saying like this. You're talking about this. This is the center particle is suppose here. So a centripetal force, Fc is always acting on it toward the center. Fc is here. And this is the tangential direction. In this direction, there is a velocity Vt. Now, if velocity and applied force, try to understand motion of the particle is in tangential direction and force is perpendicular to it. So what is happening here? Fc force is acting perpendicular to the motion. So basically it cannot change the magnitude of the force. If force is acting perpendicular to the motion, remember this, it cannot change the magnitude of the velocity. However, it can change the direction. So that's why, because here force is acting perpendicular to the velocity, that's why this force has the ability to change the direction. So direction of this velocity is continuously changed. So that's why direction of the velocity is continuously changing. Of the velocity is continuously changing. Changing. So here in this case, speed is not changing. Why speed is not changing? Because this motion is in tangential direction, force is perpendicular to it, so magnitude of the velocity is not going to change. Magnitude will change only if a component of the force is acting in the direction of motion or opposite to it. If component of the force is in the direction of the motion, velocity is going to increase. If component of the force is opposite to the motion, then speed is going to decrease. ठीक है ना? But here in this case, force is perpendicular to velocity. That's why this Vt remains constant, but its direction associated with this velocity, that is continuously changing. So that's why velocity in this case, in uniform circular motion, it is continuously changing. ठीक है? Direction is continuously changing. So this is force. Now second thing is, ठीक है? Second thing is here, come back here. I have written a statement here that linear momentum will not be conserved. Linear momentum will be conserved if force is 0. But here, at any time, ठीक है ना? At any time, force is not 0. Force is continuously acting. ठीक है? Force is continuously acting on this particle in the perpendicular direction of its motion. So that's why linear momentum is not conserved. So linear momentum is not conserved here. Linear momentum is not conserved here because because Fc that is not equal to 0 is continuously acting on the particle. On the particle. ठीक है? That's why linear momentum will not be conserved. Linear momentum will not be conserved. But remember this here, one another aspect. Just
Means
one second.
there is a magnitude of the force, means
Just 1 second.
centripetal force is not conserved.
1 second. Yes, what are you saying? Please.
Means there is a magnitude of the force. It's not-
Magnitude? A magnitude or something, force is not 0 at any time.
is
ठीक
a-
है? That
therefore
is
the
just a
linear
way to
momentum
write.
is
That is
will
just
not
a way to
conserve.
write. Otherwise, force is continuously acting. If particle is undergoing circular motion, then what is the most important requirement of the circular motion? That is centripetal force. So here, even before writing that, so for the circular motion, for the circular motion, for the circular motion, any type of circular motion, it is must that there should be a tangential velocity. There should be a tangential velocity. This is must. It cannot be 0. So, tangential velocity. This is velocity Vt. ठीक है? So there must be tangential velocity. It is must. If Vt becomes zero, then in which direction force is acting for that instant, that will be toward the center. So particle will start moving toward the center, or particle will fall into the center. If Vt becomes zero, ठीक है ना, then particle will start moving. Particle will start moving in the radially inward direction. In the radially inward direction. Inward direction. So basically one important component of any type of circular motion, not only uniform circular motion, there must be Vt. Vt cannot be zero. If Vt is zero, then due to the centripetal force acting toward the center, this particle will acquire, at that instant, it will acquire a velocity toward the center, and it will start moving in that direction. And circular motion will cease. Second, B, there must be some source. There must be some source of centripetal force. If centripetal force source is not available, circular motion is not possible. So if you want that particle should move, it will undergo some type of circular motion, then it is must that there should be some source of the centripetal force. So source of the centripetal force is must. It may be electrostatic force. It may be electrostatic attractive force. Attractive force. It may be gravitational force, which is also attractive. Gravitational force. If some car is taking a turn on the road, friction force can also act as a source of centripetal force. Friction force may be there. Okay? Friction force may also be there. Is it okay up to this point?
Sir,
Yes, beta.
sir, the question may be stupid.
Yes, please.
सर जैसे इसका जो सेंट्रीपिटल फोर्स है वो टुवार्ड सेंटर है, और अगर हम ग्रेविटेशन फोर्स की बात करें तो उसमें ग्रेविटेशन भी इन्वॉल्व होता है.
Yes.
तो
But that is negligible. What is the value of G? Suppose, for example, suppose electrons are revolving around the nucleus. Okay? Electron is revolving around the nucleus. So in between nuclei and the electron, there is a electrostatic attractive force that is acting. You call it as Coulomb force or electrostatic force. As compared to this force, gravitational force that is acting in between electron and nuclei, that will be negligible. So in that case, gravitational force is negligible. But if you are talking about larger bodies like astronomical bodies, suppose you assume that Earth is revolving in a circular orbit. It's not. But suppose you are assuming Earth is revolving in circular orbit around the Earth. Then here masses involved are so huge that this Gmm upon R square, this gravitational force, it has the ability to produce, or it has the ability to act as a source of the centripetal force. So it depends upon the mass. But if other forces that is dominating
sir,
is present, then that may be the responsible. For example, if a charged particle Suppose you are having this type of magnetic field, for example. Try to understand. If a charged particle is here, this is plus q, suppose. Then when it will enter, this charged particle will enter, then it will, this is the velocity, it will experience a force. Try to understand. It will experience a force that at any time of its motion, it will always be perpendicular. What is the magnetic force that is going to act? That will be Fm. That will be Q, V cross B. So what will be the direction here? This is V. Try to understand. This is V. In the direction of this is V. Okay. This middle finger, it will be in the direction of B. So this thumb, it is going to represent the direction of F. So here this force Fm, that is going to act as centripetal force because it is perpendicular to V. At next moment, due to this force, it will take a curvature like this. Suppose like this. Suppose your charged particle is here. Its velocity is here. This is the velocity. Now again, it will be like this. Okay, it will be like this. So again, it will be here. So every time at any point they are pointing towards some center of curvature. So here this magnetic force that is acting as a source of this curved path or circular path, whatever you want to say. Okay, so here if you look at this force and you compare this, okay, you compare this with gravitational forces, try to understand that will be negligible. If you consider the gravitational force that is acting between this charged particle, because it will have a mass. Okay, charge is always carried by the mass. Without mass, charge cannot be carried away. So charge is associated with this mass. So when this is going to interact with the Earth's gravitational field, that will be very, very small force as compared to this. So who is going to dominate? This force is going to dominate. So it depends upon problem to problem. Is it okay what I'm saying?
सर
Yes.
सर मेरा क्वेश्चन है कि जैसे अर्थ और सन का एग्जांपल लेते हैं
Okay.
तो दोनों के बीच में ग्रेविटेशनल अट्रैक्शन फोर्स होगा
Yes.
जो कि सन अर्थ को अपनी तरफ अट्रैक्ट करेगा
Okay.
और दूसरा होगा सेंट्रीपिटल फोर्स जो कि अर्थ के रिवॉल्यूशन की वजह से होगा दोनों ही इन्वॉल्व हैं
No. Try to understand, both are same. Gravitational force is acting as a centripetal force. ठीक है ना? Try to understand what he is saying. ठीक है, try to understand it. It may be in between anywhere.
सर
Suppose.
एक और एस्पेक्ट सर फिर समझा देना
Okay.
तो जब हम दोनों को इक्वल करते हैं कि सेंट्रीपिटल फोर्स ग्रेविटेशनल फोर्स के इक्वल होगा तो दोनों फोर्स ही मतलब इन्वॉल्व होती हैं
और
दोनों की डायरेक्शन
only
इन्वॉल्व है
then
तो
it
फिर
will
उनको
act as a
इक्वल
source.
अपोजिट फोर्स होना चाहिए ना
No, otherwise it will be zero. देखो, try to understand. I'm taking you a simple example. This is my nuclei. This is electron here. This electron is attracted by it. So in this direction, a force is acting. So ये force, Coulomb force that is acting. ठीक है ना? This Coulomb force किधर काम कर रहा है? This force is acting radially inward. This will be, you can write K. This will be Z times E. And suppose this is E upon whatever this radius is, R square. And this will be minus R cap. This is the force that is acting. This is the Coulomb force or electrostatic force. Now you are saying that for the circular motion, what is needed? Centripetal force. So this force is going to act as a centripetal force. So what will be the centripetal force? FC. This will be minus mv square upon r, and this will be r cap. I need some source. Some force should act as a source for this. This is not a force. This is required force. ठीक है ना? This is required force. There should be some force that should act as this one. So I need a force that is acting inward. So this force is acting, this Coulomb force is acting inward. So this can act as this. So this is minus here also. This will be minus K Z E square upon R square. And this is R cap. So this has the full capability to act as a centripetal force because it is acting inward. So if you make them equal, this minus and R cap, that will be gone, and your equation will become mv square upon R. So this is not a force. This force is required force. So there should be some existing force that should act toward the center, which is going to act as centripetal force for the circular motion. That's why you write like this, kz E square upon R square. So it will be like this. So this is the required force, not the present force. If you want that circular motion should happen, there should be some source which is going to act as minus mv square upon r cap. They are the same thing. You are writing the same thing, please. Is it clear what I'm saying?
Yes, sir. Clear, sir.
Yes, sir.
Okay. So either we need a force in this direction. That force is this one. And this is acting as a centripetal force. So that's why you are writing mv square upon r equal to this. So now come back where I was. Okay. Now for circular motion, two things are important. One, there should be tangential velocity that should be existent if you want circular motion. And second should be a source of centripetal force. These two things are must. If you want circular motion, it may be any type of circular motion, uniform circular motion or non-uniform circular motion, but these components are must. Some additional acceleration may be there, but this is must. Okay, centripetal acceleration. One more thing is there that I want to tell you here. Just 1 second. This will be. Now, what is torque?
Force in the propeller.
R into
Torque
R.
equal to tau, and that is R cross F. Okay, now this will be R cross and this will be F. Okay, so here this will be in which direction? This R vector, I can write this as R cap, or I can write capital R if I want to write. This will be R vector will be the R, and this will be R cap. Cross product, this will be, I can write, this will be minus mv square upon R, you can write, this will be R cap. So what I'm saying, this is R cap cross R cap. So this will be, okay, R cap cross R cap. So this will be 0. Try to understand. R cap cross R cap is creating here. So theta is 0. So this torque is 0. Torque is 0 in this case. In case of uniform circular motion, this is the case of, in case of uniform circular motion. In case of uniform circular motion, torque is 0. And if torque is 0, then angular momentum, this will be constant. Constant, even I should write here, L vector will be constant. Why? Because torque, that is dl, rate of change of angular momentum, and that is 0. So dl cap, this vector, time derivative of this vector is 0, so this vector is constant. So basically from here, two things are there, that magnitude of L, and that will be how much? That will be mvr. mvr. This will be constant. This will be constant. Second is direction. Direction will remain same. Direction will remain same. Remain same. So what is the direction of this? Suppose particle is undergoing this circular motion. So this is R, this is M, this particle is moving like this. Then what will the direction of L? You have to curl your right hand fingers in the direction of the motion. Particle is moving like this. So what will the direction of L? L will be like this. So this will be the direction of L vector. So try to understand. This will be ये होगा बेटा. It is rotating like this. So direction of L vector will be in the Z cap direction. So L vector will be here in the Z cap direction. And it will remain fixed. Omega का direction भी क्या होगा? Omega will also be in omega vector. ठीक है ना? Omega is also like this. So omega will also be in the Z direction. So here L vector and omega vector. ठीक है ना? L vector and omega vector, they will be in the Z cap direction and their direction will remain fixed in case of uniform circular motion. So I have discussed various aspects of this uniform circular motion on the basis of polar coordinates. Okay? So this is one of the very important problem that can be solved on the basis of polar coordinates. So in the next class, I will further discuss non-uniform circular motion. Okay? And I will also try to touch some aspects of the projectile motion where these polar coordinates are required. ठीक है बेटा. So thank you very much for today.
Sir, can I
We
show
will
the
meet
fourth
in the
slide?
next class. Welcome beta.
Sir, can I show the fourth slide?
Okay beta.
सर स्लाइड्स एक बार दिखा दीजिए.
Yes beta, please. Just 1 second. This is the first one. Second. Third. Then fourth. Fifth. Sorry. This will be fifth. Then sixth. Six. This is sixth. Then 7. Then 8. This is the last one beta.
थैंक यू सर.
Welcome beta.
थैंक यू सर.
Welcome
Thank you,
beta.
sir.
Welcome beta.